Hello, and in this video we're going to run a dependent means t-test. I'm Dr. Chris Parker and we're going to walk through slowly with this. So what is a t-test? A t-test is just a simple way of determining if two groups are significantly different. You are answering the question, did design A score different than design B? There are two kinds of t-test and we're going to cover both of them in two different videos. There's dependent means, where you have the same people tested twice, and you have independent means, which is two groups containing two different people. Today, we're focusing on dependent means. So you're going to have, sometimes it's called the paired t-test or paired samples. You're comparing the means of two related groups to determine whether there is statistically significant difference between these means. Following our flowchart, you can see it there. It is the equivalent of the non-parametric Wilcoxon signed ranks. That's because we are doing parametric statistics. We have an insignificant Kolmogorov-Smirnov test. We only have two groups and it's containing the same people. So the data we need to have unique IDs for each person. We need to have the number of groups, which is two groups. And then we've got to have a column with variables. If we've got this, then we are good. So the steps you go through are very simple. We open up our social sciences statistics calculator. We put website 1 scores in column 1, website 2 scores into column 2, and then we select the significance at 0.05, and then we say we got a two-tailed experiment. Now, what is a two-tailed and one-tailed? Well, one-tailed is when we sample from a small group of the population. So we want to know if men and women get paid differently, but we only sample the admin department. It's a small group. Two-tailed is when we sample the whole population. So normally we are going to score with a two-tailed. So you put those in, you get this kind of output, which is you're looking for the degrees of freedom, you're looking for the t-test scores, looking for the significance, the means, the effect size. Rather than just show you this, I'm now going to go and work through with you and show you how I got here and picking out the data which we need. Okay, so I've got a few tabs open on my desktop. I'm going to go through what I've got. First, I've got some data which I want to analyze for dependent means. You see here there's two groups of data. Over here in the middle, I've got my effect size calculator, which I've chosen the dependent tab for again. And over here, my favorite part is the online stats calculator. So we're doing let's open this up right away. We're doing a dependent means t-test. So we're going to go and choose this one. A whole load of information here. Don't need that. Take me to the calculator. So what I've got here is two treatments, so two groups, significance levels to choose and a tails to choose. So I'm going to go back to my data, just over here, select the scores for group 1, copy that and paste it into treatment 1. Go to the scores for group 2, copy that and paste that into group 2. Significance 0.05, that's fine, tails 2 and calculate. So what can I see I've got here? I've got a t-value of 3.76, that's very nice, but the thing that I'm looking for first is significance. So my significance level, my p-value, is below 0.05, actually it's much below that, so we've got a good test, so that's all really good. Now I want to work out the effect size, how different are these two groups? So I'm just going to go back over here to my calculator. And there's two scores I need. I need to know the t-value and the number of people. So that number of people for dependent is total number of people in the test. So that's not all the bits added together, how many bits of data we got, it's number of people. In my case, the value is 27. So the number 27 goes there. My t-score is there, so I copy that and paste it there. And we see that we have an effect size of 0.35, which is a large effect size according to Cohen. So you see that it's actually a really good difference. that is it. We've now run a dependent means t-test. So now that we have got our test completed, we're going to write it up, and I've actually gone forward and written it up for you. So a dependent means t-test was conducted on the difference between students' SUS score for the Yale Art School website and the University of Arts London website. There was a statistically significant increase in SUS scores between website 1 and website 2. All that means there is, we are more satisfied. SUS scores gone up when we look at the University Arts website compared to Yale. And you see that the mean for the first one was 37.5, and then it really rose up to a mean of 74.5. All that's out of 100, so you can see it's really gone up. T-score is 6.23. 6.23 is just a measure of how far away the groups are. Don't worry about it. Then we've got significance, 0.000. So we are very confident that our result is true. The mean difference in SUS scores was 37.2, and then the ETA squared statistic was 6.660, indicating a large effect size. So effect sizes are very important. By the way, ETA squared is just the measure for effect size that we use. Through the results, website 1 is more usable. Website 2 is more usable and satisfying. We have 9.9% certainty the difference is not by chance. It's a very large difference between the groups, and it's really good. Now the pieces we've got here, we've got the means, which you can get through Excel using average. Standard deviation we can get using stdev. Degrees of freedom is very simple. We just go for sample size -1. And again, the t-score we get from our online calculator. It's at the very bottom. Our significance, once again, is at the bottom of the calculator. The means, we get the mean difference from our calculator right there. And the effect size is quite simple. We calculate it with a simple formula, as you just saw me do with Excel. So that is all the pieces, and hopefully you can now go forward and calculate your t-test.